This is the retake video for learning targets 3 and 5. If you want to just retake 5, then I would maybe zoom ahead until you see me start talking on this screen, okay? But for those of you that need LT3 or both, we're going to start here. So this was the question on your test. You had a table and a graph, and you were asked to create an exponential equation given each. If you remember, and we talked about this in class, an exponential equation is in the form y equals a times b to the x. Okay, so that a is our start. It's our starting value. It's our y-intercept, which we all know means it is the y value when x equals 0, okay? And then b is our constant multiplier. So this is what we are multiplying by each time to either make our total go up or our total go down. If b is greater than 1, your total will go up, or your value will increase. If b is less than 1, your value will be decreasing. Less than 1, but greater than 0, I should clarify. All right? So let's take a look at this table. The first thing I notice, and the thing that got a couple of you, is that we don't have an x equals 0. We don't have a y-intercept given here. Okay? But we can find our constant multiplier and then use that to find our starting value. So if our equation is going to be y equals a times b to the x, and we're going to put a pause on a because we don't know the pattern yet to get here, where what's the female sheep when the reproduction cycle is 0, then we're going to have to figure it out. So if I look here, I'm going from 12 to 36 to 108 to 324, okay? And I know that usually in linear situations we look at those differences, okay? But our differences aren't as important here. What's important is what are we multiplying 12 by to get to 36? What are we multiplying 36 by to get to 108? What are we multiplying 108 by to get to 324? So if I wrote those questions that I just asked out as equations, they would look something like this. If I'm going to use x as my, what am I multiplying x or 12 by? So 12 times something, some number x, to get to 36. What am I numbering, or what am I multiplying 36 by to get to 108? So then, how can I solve for these? Well, if we look, you guys know from solving equations that the opposite of multiplying is dividing. So if I took 36 and divided it by 12, and if I took 108 and divided it by 36, and if I took 324 and divided it by 108, with all of these, I get a ratio of 3. Okay, so that means 12 times 3 gave me 36. 36 times 3 gave me 108. 108 times 3 gave me 324. And our constant multiplier then is 3. So our last part of our equation is going to be 3 to the x. Now we need what number times 3 gave us 12. So this time it's going to be what number times 3 gave us 12, and you guys can probably figure out what that is, or we can divide both sides by 3 in this case, and we'll get that our starting value would have been 4 right here. So our y-intercept was 4, and here's our equation. Okay, moving on to our graph. Here again, we're going to need a starting value and a constant multiplier to the x power. Okay, so our starting value is really easy. Y-intercept right here is 100. So y equals 100 times. Now we need to figure out what's going on to get from 100 to 80, to get from 80 to 64. And we're going to do it in the same way, okay? First thing I notice is that my values are decreasing. So that means my constant multiplier is going to be less than 1. So it's going to be a point something. It's going to be some decimal that makes my value decrease. And I can do this in the same way that I did before. So what number times 100 gets me 80? What number times 80 gets me 64? Well, to do that, I just divide both sides, and my constant multiplier ends up being 0.8 in both situations, because 80 divided by 100 equals 0.8 and 64 divided by 80 equals 0.8. So my constant multiplier is 0.8, and then that's to the x power. And that makes sense because I have exponential decay here, and so I would expect my number to be getting smaller by multiplying by 80%. Okay? So that's LT3. Go ahead and if that's all you need to do, then what you're going to do next is below this video, which I'm going to put this video under Unit 7 on the Algebra website. If you go over here to Retake Videos, I'm going to put this video right here, and then you'll see there's some con problems. Okay, so LT3, graphs of exponential growth. And then there's also some Learnzilla problems if you want to try that. What you have to do, though, is this retake practice. You have to take this retake practice and go down here and write exponential equations for these two situations. Okay? All right. So if we're moving on to LT5, and LT5 is where the people that skipped ahead, you should be here. We are asked to model exponential equations to fit a real-world context. Our first context has to do with a bus company. It raises the price of its tickets by about 3.4% each year. In 2005, the price of a ticket from Dallas to New Orleans was $80. You were asked to write an equation that can be used to calculate the price of a ticket from Dallas to New Orleans for any year. You're asked to use Y to represent the price of the ticket and to use X as representing the time in years after 2005. Okay? So here, really what we need to do is we need to pick out our starting value, and we need to pick out our constant multiplier. Okay? And when we are dealing with percentage increases, remember B kind of turns a little bit. B turns into one of two things. Our B is the constant multiplier. So that's going to be either we're keeping 100% and then adding on more percentages, or we're keeping we're taking 100% and we're taking off a certain percentage. Remember, this R is the rate of change, right? Or the constant rate. So in this case, they are increasing ticket sales by 3.4%. Okay? So my R value, my R is 3.4%. So if I'm going to change that into a decimal, that's going to be 0.34%, or 0.34, excuse me. And since our prices are increasing, I'm going to take that 100% and add 3.4%, or 0.034. So my B value in this case is going to be 1 plus that 0.034 for representing 3.4%. So that's my constant multiplier, the 1 and the 0.34%. Okay, some people used just 3.4, some people did some different things there, but that's my constant multiplier. The 1 is probably the biggest thing people forget. My starting value is 80 because in the year 2005 they were sold for $80. All right, and so really that's my equation. It doesn't ask us to calculate anything, it just asks us to create that equation. Moving on then, here's where we have some calculations to do. So we're assuming there's a painting value that increases by 7% each year. Right away, guys, I'm just going to turn that 7% into a decimal. That's going to be 0.07%. or is 0.07 is 7%. For each question, you're asked to write an expression in this form, a times the quantity 1 plus r to the x, and then evaluate the expression to use to answer the question. All right? So the painting is worth $2,000 today. That would be our A. And 1 plus 0.07 is what's going to be our B. How much will it be worth in 40 years? That's going to be our exponent. So for this one, you should have set up that we had $2,000 times 1 plus 0.07 to the 40th power, okay, which equals 29,948 and 92 cents approximately is what the value is worth. Okay, so that went up in value. A painting is worth $5,000 today, and our constant multiplier is staying the same. How much was it worth 3 years ago? Now, ago means it's increased in value to $5,000. So 3 years ago, it was probably worth less than $5,000. So how do we represent less than $5,000? What am I going to do? I'm not going to take this times 1.07, but I'm going to divide by 1.07 because my value is increasing, or I can use a negative exponent, so 3 years ago, and that would be $4,081.49 is what that value was. And then finally we're asked $3,000 painting from 2 years ago. That would be worth $3,434.70 today. All right, so those were pretty self-explanatory. People either got them or they didn't. So we'll move on to this rubber ball that rebounds to a height that is 15% less, and I'm going to just go ahead and turn that into a decimal. That's 0.15 less than its previous height. Okay, so how high is the first bounce if the ball is dropped from 200 centimeters? Well, 200, that's going to be our starting value. So 200, and then we're losing 15%, so times 1 minus 0.15, or that would just be 200 times 0.85, and this is just after first bounce, so just to the exponent of 1, and that would be 170, right? Okay, and then you were asked to record each bounce height. Well, if we write an equation, then you can do that. So if we write an equation here, our starting value was 200, okay? And our R value was 0.15. And since this is decay, since it's 15% less, then we're going to take 1 minus R, okay? So 1 minus 0.15 to the x power. Or that would just equal 200 times 0.85, because if we're losing 15%, we're keeping 85%. And that is the equation you could use to plug those in. So whether this is you just watching LT5 or you having to retake LT3 and LT5, now you have some work to do after you've watched me correct the test and kind of give some clarifying questions here. So on the algebra website, you need to go to the, on the side here, exponential equations, to the retake video. I'm going to put this video right here, and then you can do some practice on either LT3 and 5 or just 5, or do some more practice on this LearnZilla, and then what you have to do is take this retake practice sheet, skip the first page. If you want to do that, redo that stuff, you can. But you have to do this second page here for LT5. Okay, so you need to do that second page, come with that and any questions you have to your teacher, and we will help you to make sure you have these 2 learning targets down.